All right. If f of x equals x squared minus 4, and g is a differentiable function of x, what is the derivative of f of g of x? So we want to put g of x into x. So f of g of x is g of x squared minus 4. So now we can go ahead and take the derivative. Power rule, 2 times g of x to the 1 times the derivative of the inside, chain rule, g prime of x minus 4. And I think that shows up. This is a 1. Yeah, that's what I was getting confused on. So I think that shows up right here. 2g of x times g prime of x. And let's try one more practice problem. If the f double prime of x is x times x plus 2 squared, then the graph of f is concave up for which values? So concavity is the second derivative. So we want to know when it is not concave up or down, so we can find when it is 0. If I set that equal to 0, x equals 0, or x equals negative 2. That tells me when it's 0, so it's neither concave up nor down. So let's see if it changes with our second derivative test. Negative 2 and 0, and then we'll just test points. If I put in a negative 3, we're just looking at our signs. I get a negative times something that's always positive, which is a negative, so that's concave down. If I put in a negative 1, I get a negative times something that's always positive, which is still negative. And if I put in any positive number, I get a positive times a positive, so it's positive. So the graph is concave up for anything greater than 0. All right, kind of looking at 6.1.2 then. We're doing derivatives of exponential functions, which we kind of all went through yesterday. And actually, if you look up in our sign up here, it's got our definition that we wrote down. So there's still some that we cannot yet differentiate. I would like you to spend a second and write down other functions other than exponential, because there are some that we cannot differentiate. And then also spend a minute and make a list of any techniques that you've used to find slope functions, which are derivatives. All right, now let's look at 18. Derivatives of exponential functions, part 1. All right, so we did that yesterday. We've got that definition. We're going to skip the natural log investigation. The only neat thing about this is finally, what we did want to see was in 19, they finally solidify why do we use radians. We use radians because in calculus, we know that the derivative of sine is cosine. But that's only the case when you're measuring in radians. You can try that in your calculator. The sine of, you can look at the curve and look at it in degrees and radians, and it only works in radians. And then yesterday we talked about the derivative of e to the x is e to the x. So now we're going to look at, we're going to skip 20. We're going to go right to 21, and we're going to do some of these problems. So I'd like you to try them in your teams. They really, kind of like examples we looked at yesterday. Shouldn't take too long. And then we'll just kind of go through them. If y equals 5 to the x, the derivative is the natural log of 5 times 5 to the x. No problem, just leave it like that. And then b. Now, yesterday I saw some kids trying to use a product rule here. It does say times, but this isn't. This is a constant function, and the derivative of a constant function is 0. So it's really just a multiplier. So y prime equals 3, and then we can just picture the derivative of 7 to the x. Natural log 7 times 7 to the x. And then finally here in C, I like that they led with b. We've got, again, just another multiplier. And we can just leave that 1 over the natural log of 5. That stays right here. That's just our multiplier. Times the natural log of 5 times 5 to the x. So you can kind of see what they did there. Those are going to multiply to 1. So the derivative of that is going to be 5 to the x. And I'd ask you, what do you think they're predicting there, or kind of previewing as they ask that question? And then 22 is just practicing our derivatives. So let's take a look. F of x is 3 to the 2x plus 3 to the x minus 1. So we've got that plus. We can just take each derivative separately. The derivative of 3 to the 2x, what's that going to involve? That's going to involve the natural log of 3 times 3 to the 2x times 2. Where does the 2 come from? The chain rule. The derivative of 2x is 2. Plus the derivative of 3 to the x minus 1 is the natural log of 3 times 3 to the x minus 1. Now this one's going to be times 1 because the derivative of x minus 1 is 1. Got a little dog playing with the bone down there. Equals f prime of x. Now b is going to involve a... All right, in the next one we're definitely going to say times. So we've got our product rule. So I'm going to just write them over here. 2 to the x cubed. The derivative of that is the natural log of 2 times 2 to the x cubed times 3x squared. There's our chain rule. The other one we've got is tan x. The derivative of tan x is secant squared x. So then we do our 2/3 bow tie. Two to the x cubed times the secant squared of x plus, I'm going to write tan x times, whatever order we want, natural log 2 to the x cubed times 3x squared. Long derivative, but our basic product rule, chain rule, and now our exponential. And finally, in the last one, we've got an addition again. So we can go the derivative of e to the x is e to the x. So we rewrite e to the cosecant x times the chain rule, derivative of cosecant is negative cosecant cotangent, plus the derivative of 5 to the x is the natural log of 5 times 5 to the 2x times the chain rule of 2. Good. And then I would just start on homework and do some practice. Maybe redo those.